Now let's see how to define a custom delegating code. In this simple example, we have two static methods, the sum and the subtract methods here. They both take two ints as a parameter and they return an int, the result of the calculation. Of course, we won't be surprised if we are calling them directly with, for example, 5 and 5 parameters. We will get 10 by calling sum, and we will get 0 by calling subtract as the result. So let's try this out just to make this sure. So I will first call sum with the mentioned 5 and 5 parameters, and then the subtract with 5 and 5 parameters here. And since these methods return in integer, we need to write console write line because we would like to see the output result on the console. So let's write console.write line here very quick. And now if I run this, we can see that we get 10 and 0 as the result, just we expected. But what happens if I don't want to call these methods directly, but I want to use a delegate for the method calls? This is also very easy to do, and it happens the same way we have seen earlier on the slide. First, we need a delegate declaration for this. So I will make this declaration first here in this file and also here in the namespace, so that other classes can use it as well, maybe later on. And I will make it here and write public. We need to use the delegate keyword. And since these methods return an int, we need to write an int as well as the return type. Then we need to write the delegate's name, which will be numbers process delegate in this case. And then the parameters here, the reference methods we'll use. So the reference methods are the sum and the subtract we want to use for delegation, and they take two integers as a parameter. So we need to write int x and int y here as well. So we have our delegate declaration now, but in order to use this, we also need to instantiate this delegate type, just like you saw on the slide. Let me just first get rid of this direct invocation here. So I will delete this, and I will instantiate new object of this type, new instance here. I will call the variable del, and let's make this equal to new numbers process delegate. And now you can see that this actually takes a method as the target. And this method needs to have two int parameters and need to return an int as the result. Since we have two of these methods, we can use either sum or the subtract, but let's try it out first with sum. So I write sum here, and we can see that it compiles perfectly. To invoke it, we need to use our del variable, and we'll go ahead and invoke this variable just like we would invoke a method, and pass in 5 and 5, just like we had earlier. Of course, we need to write it out to the console as well, just like we wrote it earlier. And now if I run this, we will get 10 as well, just like we've gotten before. Because actually what we did here is that we created a new delegate here, and we instantiated this delegate. And through this del variable, we were able to point to the sum method here. So by invoking del and passing in 5 and 5 parameters, pointing to this method, we could simply invoke it. And we are also able to change this to subtract if we want to, by just quickly modifying sum to subtract here. And now if I run this, we will get 0 as a result. Notice that when I was changing sum to subtract here, I wasn't touching this invocation here. So I was able to do this without modifying the invocation with the 5 and 5 parameters. And this is not very useful yet, because you may ask the question that Why isn't it not enough for us to call this method here directly? Why do we need to create a delegate here and create a new instance and invoke it through this variable? And that's what we are going to cover next.